In this video, we're going to look at analyzing the graph of a y equals tangent function as variation. So tangent x and cotangent x are both odd functions, which means the tangent of negative x is equal to the negative of tangent of x, and cotangent of negative x is equal to cotangent of x. So here is one period of a tangent function that has not been shifted horizontally or been compressed or stretched. So negative pi over 2 to pi over 2. So it's undefined at negative pi over 2 and at pi over 2 because it's sine over cosine, and cosine is 0 at pi over 2 and negative pi over 2. And so we get these values, though, for negative pi over 3, negative pi over 4, pi over 6, 0, pi over 6, pi over 4, pi over 3, up to pi over 2. So at pi over 2 and negative pi over 2, here's a graph. You see we'll have these vertical asymptotes. So we get this kind of a curve like so. You should see that there. That's our curve. It approaches these asymptotes. So graphing variations of y equals tangent x, y equals a tan bx. The stretching factor is the absolute value of a. The period is pi over b, so not 2 pi over b like we saw in sine and cosine, but pi over b. The domain is all real numbers x, where x is not equal to pi over 2b plus pi over b, absolute value of b, I should say, k, such that k is an integer. So we get our vertical asymptotes every pi. So once you know you get to that pi over 2, b times b, every pi over b is your next vertical asymptote. Okay, the range is negative infinity to infinity. Asymptotes occur at x equals pi plus, pi over 2 absolute value b plus pi over absolute value bk, where k is an integer, and y equals a tangent bx is an odd function. So, I mean, there's a lot of information here, and I almost feel like going through it like this can be more confusing. I think it's easier to get down here and graph it. Excuse me. So graphing one period of a standard, one period of a stretched or compressed tangent function, you're not going to notice that much because it already extends to infinity, negative infinity. So you might see some of those middle values, like the ones around 0 from the y-axis. It will get stretched up a little bit, but that's really all you're going to see. So identify the stretching factor, absolute value of a. Identify b and determine the period, p equals pi over absolute value of b. Draw vertical asymptotes at negative p over 2 and positive p over 2. This is kind of an interesting approach to see it written that way. Anyway, for a being greater than 0, the graph approaches the left asymptote at negative output values and the right asymptote at positive output values. But if a is negative, your leading coefficient is negative, it'll be going basically up as you go to the left and be going down as you go to the right. So that's if a was negative. So plot the reference points and draw the graph. So we're going to sketch the graph one period, and I just screenshotted a graph. This is not a special graph. This is just a graph. You probably saw this in other videos. It was just a resource out there. So y equals 0.5 tangent of pi over 2x. So let's go ahead and look at a couple things. The period, I don't know why it's not blue, but turn it to blue. It already says blue, but it's not there. Okay. The period is going to be pi over the absolute value of b, so pi over 2, which is just b2. So that's our period, and so we cut that in half. So maybe I should just get rid of all these values like I did earlier in the other graphs I did. And we'll just scale it the way we want to scale it. Like I can call this 1, call this 2, call this 3, 4, negative 1, negative 2, negative 3, negative 4. And we would have the asymptotes at 1 and negative 1 because this has not been shifted horizontally. By the way, we'll have 2 later, so at 3 there'd be 1. At negative 3 there'd be 1. And then we know that it would cross, let's see if I can change colors to green. It's going to cross the x-axis in the middle there, I guess there, and here, and here. Okay. Now all those other values are going to be half because our leading coefficient is half. So, and we just have to kind of think of this place here at 1 would have been pi over 2, but now it's 1. We know that this location here is like the pi over 4 location, right? This area here. So that would have been tangent of pi over 4 is 1. So we can plug in values to get that too. Maybe we want to say when x equals 0.5, we're looking at 0.5 times tangent of pi over 2 times 1/2, which is 0.5 times tangent of pi over 4. Tangent of pi over 4 is 1, so we get 0.5. So that means I'm going to go do this here. Erase that. And likewise, we'd have one down here. So it's going to be coming up like this. It's going to be coming down like this. Likewise here, across there. And this would be coming up like that. This would come up, across like that. And this would be like that. So that's roughly how the graph would go. Okay.